Hi everybody. So in this lesson we're going to look at the discriminant, what it is and where we use it. So firstly, in the formula booklet, section 2.7, we are given this. This is our quadratic equation and the formula, and this is the discriminant, b squared minus 4ac. It is this part of the quadratic formula. And it is denoted using capital delta, which is basically just a triangle like this, and it is b squared minus 4ac. Now, what we use it for is to decide how many roots the quadratic function has, or how many solutions to the quadratic equation. And the reason we can use the discriminant, where it comes from, is this quadratic formula. So imagine, like this is in the square root here. So imagine, let me just get rid of that. Imagine b squared minus 4ac, or the discriminant, is bigger than 0. Well, what happens is, so let's say we had square root of 9, for example. What happens is you get plus, the square root of 9 is 3, so you get plus 3 and minus 3. So you get two distinct, and that's the word I'm going to use down here, distinct. You get two distinct real roots. One of them is plus 3 and one of them is minus 3. Two distinct, meaning completely different roots. If it equals 0, what happens is you get the square root of 0, which is plus 0 minus 0, which is actually the same thing. So you effectively only get one root, or one solution. Now we call it, instead of saying one root, we say two equal roots, which is a bit silly, but that's what we say. Or we say one repeated root. I'll explain more what that means graphically down here, but let's just go through this. So if this equals 0, we have one root or two equal roots. And then if this is less than 0, what happens is, let's say we have the square root of negative 9. Well, the square root of negative 9 we cannot do. There is no square root of negative 9 unless you start studying complex numbers in higher level. But let's not get into that right now. If the square root of a negative number, we cannot do. You cannot square. If you square negative 3, you get 9. You don't get negative 9. So there's no square root, giving us no roots. Okay, now what that means graphically, if the discriminant is greater than 0, we have two distinct real roots. Now what that means is that's your kind of normal quadratic, and it crosses the x-axis twice. These are your two distinct roots. If you had the negative quadratic, it would go up and down, and it crosses in two places. I mean, it could be anywhere, depends on the quadratic, obviously, but we are just focusing here on the number of roots. So here we have two distinct roots. If we've two equal roots, or one repeated root, what happens is it comes down, but hang on, that's poorly drawn. It comes down, but it turns exactly on, that's also poorly drawn, on the x-axis like this. So it touches the x-axis in only one place. Or the negative quadratic, like so, touches it only once. So there we have our one repeated root, or as I said, we say two equal roots. And then finally, if it has no roots, what happens is it comes down and it doesn't touch the x-axis at all. Or the negative one doesn't touch the x-axis at all, like this. Okay, so let's look at two examples. The first one is fairly straightforward, and then the second one is an exam type question. So first it says, use the discriminant to determine the number of solutions to the equation this. So this is our equation. How many solutions does it have? So it either has 0, 1, or 2. The way we find it is using the discriminant. So I'm going to say the discriminant, which is b squared minus 4ac, that's in the formula booklet, is equal to. Now I always write at the side a equals 2, that's my a, the coefficient of x squared. B equals negative 3, that's my b, negative 3, be careful. And c is equal to 5, it is the constant that is left over. So I have b squared minus 4ac, so b is negative 3 squared minus 4 times a times c, which is 5. 9 minus 4 times 5 is 20 times 2 is 40. 9 minus 40 is negative 31. So negative 31 is less than 0. Therefore, there is no solutions to the equation. So the discriminant tells us how many solutions. So I know this has no solutions. And if I was to draw that, it would probably, well, it would look something like this. A smiley face that doesn't touch the x-axis. I think it's probably over here somewhere, but it will not touch the x-axis. Finally, I'm going to do a past paper question. This is a little bit more tricky because they've included k's in the function. So here it says, consider the function, this, find the value of k for which it has 2 equal roots. So it tells us now there are 2 equal roots. Now when I see these words 2 equal roots or 2 repeated roots, or sorry, 1 repeated root or no roots, that tells me, and you need to get used to seeing, when you see that, you know it's discriminant. So just for writing discriminant, often, you have to check each mark scheme, but often it says use of discriminant anywhere is worth a mark. So if you recognize that you need to use the discriminant here, you'll get a mark. So just for, actually, if you just drew this triangle and left the whole page blank, you'd get a mark. Okay, so I want the discriminant, and then it says 2 equal roots, so this equals 0. And in fact, sometimes I've seen mark schemes where if you just wrote this, you'd get 2 marks, because 1, you've recognized to use the discriminant, and 2, you've recognized that for 2 equal roots, it equals 0. So b squared minus 4ac equals 0. Now, I am going to write at the side a equals 1 minus k. Now be careful. A is, it's the coefficient of x squared, so it's all of this. It's in a bracket. B is equal to 1 because it's like 1x. That's my b. And then c is going to be k. Sometimes I've seen functions where it's like plus k plus 10. And in that case, c is k plus 10. So just be very, very careful there. Right. B squared is 1 squared. So that's 1 minus 4 times a is 1 minus k. And c is k. And this equals 0. Now I just have to solve this. So I'm going to do 1 minus, I'm just going to do this to make it a little bit easier to see. I'm going to join this. So I'm going to do the 4k first. So it's 4k, 1 minus k equals 0. Sometimes students mess up here when they're multiplying 3 things. So try and just break it down, make it as easy as possible. So this is 1 minus 4k times 1 is minus 4k. And now I have negative 4k times negative k, which gives me plus 4k squared equals 0. Now I have a new quadratic with k's. So it's 4k squared minus 4k squared minus 4k plus 1 equals 0. I'm going to factorize this. I'm going to do this quickly. So it's 2k and 2k, and it's 1 and 1. Factors of 4k squared are 2k and 2k. Factors of 1 are 1 and 1. Both signs are the same. Both signs are negative. If you are not familiar with what I've done there, check out my lesson on factorizing. Okay, let me just go over here. So 2k minus 1 times 2k minus 1 equals 0. So the only thing I have is 2k minus 1 equals 0. 2k equals 1 and k equals a half. So that's the only solution. Put a box around it to be clear. This is the only solution that would work, that would give me 2 equal roots. And that's why it said find the value, not the values. So k has to equal a half. Okay, so I went through that pretty quickly. Obviously, just watch it again and slow it down if you need to. This particular question, what is obviously essentially important that you understand is this. If it is 2 distinct roots, the discriminant is greater than 0. 2 equal roots or 1 repeated root, the discriminant equals 0. And finally, no real roots, the discriminant is less than 0.